Good morning. How was the earthquake?
Traumatizing.
Band trip people. It was cold. Not scary. Okay. They had an earthquake at 4.7, 4.8. Went off 50 miles from New York City where all of the band people were. It's like, haha, special surprise for you. You weren't scared?
I would feel it. Like, we were in the elevator and some lady was telling us that our building was like going back and forth. But
Do you guys remember the earthquake that was here? You were like little. Yep. Cool. We don't get that on the East Coast. It's disturbing when we do. All right. Well, so finishing out things. I sent a reminder of stuff. Most of you did the AP Classroom thing. A new one opened up today. You should have gotten an automatic email, but don't know if the time it did go. Okay. Then I wrote it a week and a half, 2 weeks ago, and it was like 6 a.m. on break. Might have been the wrong thing. But there's a new one open. It's due Sunday. And most of you did them right. But best advice to not run into issues and losing progress is to do it all in one sitting. And as I said in one of the emails, some people like Brooke was like, I did it all on paper and I took a snapshot. Okay, cool. Retakes are tomorrow. If you are doing them, you needed to sign up and let me know. And you need to turn in corrections before that, which is lunch tomorrow. Starting polars today. It's the last section of chapter 10. We did some of this before break. But if you can draw this triangle, you can get all the polar equations. Pick any of the three letters, x, y, and theta. Okay, well, tangent of theta is y over x. How about x, y, and r? Okay, x squared plus y squared equals r squared. Pythagorean theorem. X, r, and theta. Cosine of theta equals x over r. Sine of theta equals y over r. So if you can draw that triangle, you can get all the information you need. On the way we do. That is mostly what we're going to be doing. Reasonable, Alex? Yeah? And most of you aren't going to draw the triangle anymore. You're just going to be like, well, x goes with cosine, y goes with sine. Just got to remember there's a stretch of that, whatever the radius was. Pre-cal, this isn't new. This is pre-cal. Reasonable? What makes it calculus is now the radius is going to be an equation in terms of theta. Some people are still writing them out. I'm excited for the eclipse today. Have your glasses. Don't go blind. Don't do like the Donald and stare right at it. It's one of my favorites.
I don't have
You just get
sunglasses.
one on top of the other.
Wait, yeah.
Do you guys remember how to graph these? It's not a big deal, but knowing being able to plot two coordinates in polar and so you know which way things are drawing is a good idea. This is radius comma theta. So facing 15 degrees, walk out from the origin 1, 2, 3, 4. This is facing 15 degrees, walk backwards. It's not really a negative radius, it's an inclining direction. So that, 1, 2, 3, 4. And facing negative 15 degrees, walk forward, forward, backwards. Good? You know? Rare for them to ask these things, but again, just to remind you, if I need to convert this rectangular to polar, I need an R and a theta. Josh, how do I find R?
X squared plus Y squared, so it's 3.
Okay, so x squared plus y squared equals r squared. 4 plus 49, r is square root of 53. And you would need a calculator. Tan inverse of 7 over 2. Not only need a circle, and it would give me some positive angle, like 70. But because the quadrant it's in, I need to add 180 to it to get that other one. Yep. And converting this to rectangular, the x is the radius times cosine of 60, and the y is the radius sine of 60. Looking, these were the kinds of polar questions that would be on the AP exam in the 80s and 90s. Yeah. We're a couple decades past that, so I think you're safe. But sketching the graph, x squared plus y squared equals 4, what does that look like? Circle with a radius of 2, centered at the origin. And if you needed to change that rectangular equation to polar, what did Josh say in the beginning? X squared plus y squared equals what in terms of it equals r squared? So the polar equation is r equals 2 or r equals negative 2. That's all. Okay. I want to actually get to some calculus. Showed these to you before. Question? This is what a polar equation looks like. That's its rectangular. This part where it dips below the x-axis is where it makes that inner loop. You might need to find where does that inner loop start to happen. What is the radius when it pinches closed? Like what is the radius right here? What? All right. Sean, when I put in 0 for theta, what do I get?
Yeah, 3.
So facing 0 degrees, go out 1, 2, 3 units. Cool. Preston, when theta is pi, plugging in pi, what do I get? Negative 1. So facing pi, walk backwards, -1. What is the radius when it hits the pole? 0, like it had to have happened somewhere. So where does this equal 0? Subtract 1, divide by 2. This is something you might need to do. Find where does the radius, like they'll ask, can't believe they asked this, but they've find the area of the butthole. So you need to know where does cosine equal negative 1/2, which is where? Marco?
Pi over 3.
2 pi over 3 and 4 pi over 3. So this starts to draw that loop at 2 pi over 3, and it's closing the loop at 4 pi over 3. So you need to know where to set up your interval limits. So you might need to do that. In general, you don't need to know what these look like. It's helpful to remember sine curves, they're gonna hug the y-axis. Cosine curves are gonna hug the x-axis. And the number in front just makes the diameter of that circle bigger. These are pre-cal slides, by the way. Sine 2 theta and sine 4 theta. 2 theta, how many petals did that make? Do you guys remember? 4, yeah. And the number in front just controls how big the petals are. And again, you don't need to know so much what they look like. They often give you the picture or let you use a calculator or both. Those guys, when the number in being added is bigger, it's going to have a dent. And if you think about it, sine can be -1 to 1. So the biggest this is going to be is 7, and the smallest it's going to be is 4 minus 3, which is 1. If these numbers were traded, what is the next page? It is not. If it was, these guys were 4s and the 1 was here, then it's going to make an inner loop because the negative radius is going to be big. Okay. To show you what you need to do with these with calculus. Wow. All of that, you already did. Okay. So did you guys, Polar's not, was a whole week of pre-cal last year. Any issues with the review? Okay, well then here's Polar's on calculus. Like I said, x r cosine theta, y equals r sine theta. We're okay with that. But now, find dy dx. Any guess?
Can I use that? Wouldn't you have to do like when you like multiply, so you would f times theta times cosine and then.
So we gotta do product rule?
Product.
Gross. John?
Is it, we take the x and do it respect to theta and then put them over each other?
Okay, so it's combining two things from the past that we're not fans of. So we need to do product rule, and like parametrics, we did dy dx over, or dy dt over dx dt. I need to do dy d theta over dx d theta, which is what Sean is saying. And Nina said, all right, we need to do product rule. So y is first times the derivative of the second plus second times the derivative of the first. Then over dx d theta. First times the derivative of the second plus second times the derivative of the first. I don't recommend memorizing this, just applying product rule and making a quotient. And Ari, you're in luck. I have never seen them ask double derivative because that would be an expletive mess. Just for you. I ordered it. I think you have a question, you have a look. No? Okay, so, try it. Here's the equation of the curve. And they want dy dx. Do you have an x or a y equation? No, so how do we? Greg, what are the x and y equations? Hint, hint.
It's just hard because data.
Except what is r? In this problem. There you go. Well, do you have just a big horrible mess?
It's like really long. I don't know if it's right.
Okay, well, to try and guarantee that we don't get it upside down, let's do dy d theta first. So product rule, what is dy d theta?
Me?
Yeah.
2 sine 3 theta times cosine of theta plus sine of theta times 2 cosine 3 theta times 3.
Yes, no? All right, okay. So isn't there a chain rule? So first times the derivative of the second, 2 sine 3 theta times cosine. Then there is no chain rule for that one because the derivative of theta is 1 plus sine times the derivative of this. And then chain rule, so you did say the 3 and I didn't write it, okay. Thank you. We're talking faster than I could write. So now do we agree with that? That's not the whole derivative. All right, so Alex, what's the dx d theta?
2 sine 3 theta times cosine theta, plus 6 cosine 3 theta times sine theta.
Sorry, you said,
I just moved the 3 times 2, like the radical to the front.
okay, so, sorry, what was the second part?
Well, I wrote it as 6 cosine 3 theta times sine theta.
But the derivative of cosine, did I lose the negative? Did you say it or?
No, I missed that. So, just derivative of cosine is
Okay. First, times the derivative of cosine. And I could have just written things wrong.
No, I told you the wrong one.
Okay, plus second unchanged. Okay. I don't know, Alex. I don't know which
No,
one of
no,
us.
no. I messed up. I gave you the
I'm not doing well with my listening
No,
today.
no, I had them written dx. Yeah.
Okay, Gabriel.
For dy, at the end, shouldn't it be 2 cosine 3 theta?
Okay. So this one first times the derivative of the second plus second times the derivative of 2 sine blah blah blah. Okay. And she might have said it. I am just not hearing right. Did you say it correctly and I wrote it
I
wrong?
haven't written it down correctly.
Okay.
I could have said it wrong.
Okay, now let's make sure. Now this dx d theta here. First times the derivative of cosine, which is negative sine. Okay, plus the second. And Alex said we tried doing it backwards and it's just got all messed up. Derivative of the first, derivative of sine is cosine. And then chain rule. Okay, that wasn't supposed to be the hard part. For these, right here, I would not simplify this anymore. If they're just asking, what is the slope at pi over 6? Plug it in. Sine of 3 times pi over 6. What is 3 times pi over 6? It's pi over 2. Sine of pi over 2, 1. So this is 2 times 1 times cosine of pi over 6. Root 3 over 2. Plus sine of pi over 6. Half. Over here, cosine of 3 times pi over 6. Cosine of pi over 2, 0. So forget it. I don't care about the rest of that stuff. It goes away. All that over sine of pi over 2 is still 1 negative sine of pi over 6. Sine of pi over 6? A half, and it was negative. And then here I got that cosine of pi over 2 again, that goes away. So what does that reduce to? Negative root 3, period. If you try and clean this up, it's just going to be a nightmare. I recommend once you get that big nasty business, just plug in the angle they're asking. And the graph of 2 sine 3 theta is that little flower loop there. Odd numbers in there give you an odd number of petals. And the slope right here looks like a negative slope. Seems like we could have gotten it right. God help us all if they're like, yeah, no, find the tangent line. But it's not that hard. To find the tangent line, you take the x and y thing that Grady told us, plug in your pi over 6 to the cosine theta as well as the equation for r. It's just a mess. Yay. I have one more idea in polars. Let's see. I forgot to bring this up in advance. It's doing the loading. Kai, what's the area formula of a circle?
Pi squared.
Pi r squared. Okay. Sorry. Luke, if that was just 20 degrees slice of pie there, how much is that sector? What's the area of that? So you're doing, how much of the pie is 20 degrees? So 20 degrees over 360. Do we work with degrees in here? No, like never. So, all right, fine. Let's make it radians. We'll do pi over 6 radians. The area of that sector, how would I need to adjust this inside to be? So how much of the angle in radians over a full circle in radians? So this reduces to the angle, pi over 6, and half of r squared. Okay. And these demonstrations aren't working right at the moment, so we'll try to get them to come up to show you in a second. But let's say I wanted to find the area of one petal. It's not a circle. I need to find that sector, this sector, that sector, instead of like rectangles. This is Riemann sum getting all whacked. I'm setting up little triangles. Is that following with this so far? So area of the sector was 1/2 radius as an equation times the change in the angle. Over all of those angles. So maybe 0 to pi over 3 to find that one petal. Anytime you're giving it a look.
Why is the, like, why is the 1/2 there?
Why is the 1/2 there? Because if this was not pi over 6, it's any old angle in radians, any old angle in radians over 2 pi, over times pi r squared, those pi's cancel. So I still have the 2 underneath, and I have the r squared up top. And then I have my theta, which theta in my integral is this business. Josh?
Oh, how do you do 20 degrees radians? Wouldn't that be pi over 9 if you were to do like times pi over 40?
Yeah, well, first of all, they're never gonna ask you this in degrees. But most of you are more comfortable in doing 20 over 360 and being like, okay, yeah, it's 1/18 of whatever the area is gonna be. But there's our formula for finding polar area. I have it nicely on the next page. I do. So those little scribbles are an alpha and a beta. So it's 1/2 the function of the radius squared. Can we try a problem? People are still writing. Sorry, I need to steal some links for a second. So not a great demo, but to show you we're finding sectors out like that and then integrating all of those little slices together. So with this problem, can you find the area of the whole cardioid? There are many valid ways to go. Give it a try. doing a lot of this.
That's what I'm saying.
So they
It's like
might-
who's speaking Italian?
What's the first half? You know what? Just like, just being right.
Just being right. Okay, what's being right? Bring it.
Right. Okay, I said it.
Oh, well, that's not very exciting.
Well, I haven't hit it.
Sorry, my family, if you didn't
No, it's
understand,
fine.
I started shouting in Italian.
Yeah.
Come on, you get it, right?
A lot of gesture.
Like, I did look for, I was
How do you find the bounds? Good question.
It is also.
Okay. So,
Yeah, and, it's just going off the art. Does say stuff.
as strictly written, this is what we're doing. 1/2 the radius, be careful with the parentheses, squared d theta. Question was, how do you find the bounds? Well, we want to find the whole shape. So how many, this is where pre-cal is needed. How long did it take to draw the whole thing out? 2 pi. So it's, we would integrate from 0 to 2 pi. Eitan, what are you gonna say?
I was gonna ask, can you, like, is it symmetrical? Like, it's,
Is it?
yeah, it's symmetrical. Could you do like 2 times and then 0 to pi?
Absolutely. And then this 2 up here bugs me. I fear that you will lose that 2, and that 2 gets squared also. I would bring a 4 out and do the 1 plus cosine squared. These are generally calculator questions. We can technically integrate this by hand, but you need a trig identity and fancy business. So this would most likely be on a calculator. And if it is on the calculator, you will do that opening parentheses, but you will close this one and square just that. So see what you get on a calculator. You can do either of these, so Eitan, that we're not doing it by hand, seeing the symmetry, doesn't help a lot. But yes, great.
Okay, in my sense, there's this equation. She then she said that she's yeah. I know.
Wait, should we set it to the
No, doing the integration.
Rather than give others here.
Oh. Yeah, I got you. 1.84. Okay. Yeah. Brought to 5.
6 pi? 18 and change? So there, it can be done by hand, I do not recommend it. So I took this over, expanded, I used my pre-cal to get what cosine squared is, and integrated all the things. And thankfully, I'm plugging pi and 0 into a whole bunch of sine functions, so most of them go away. Yay. So the tricky thing with polars is that you need to possibly figure out the bounds. I have seen them ask, what's the volume of one petal? And this one's super tricky. How long does it take to draw 3 petals out? Is it 0 to 2 pi? It's just pi. And do you guys know how to turn the animate on and watch the polar graph go? 5 of you are shaking your heads. 5 of you are going no. And the others are like, what? Okay, we can look at that tomorrow because the bell's about to ring. But if you go into polar mode and type it in and arrow all the way to the left and animate, you can watch it draw. And in 0 to 2 pi, it'll draw itself twice, which meant 0 to pi, it went once. So how long does it take to do 1/3 of that? 0 to pi over 6. And you know what? It doesn't matter if you get this half of the petal and that other piece, they glue together to do the same. Yeah.
How do you know
This is having familiarity with the graphs and pre-cal that we made you graph them by hand, usually at least for a few days. And you can see that it took 30 degrees.